Okay, I'm going to go over a couple of Charles's Law problems from the notes. Practice problem 4.5 and 4.6. So let's get started with Charles's Law. Again, you should have your notes filled out up to this point. We've got the sample problem here, and I'm going to do practice problem 4.5. If a sample of a gas occupies 6.80 liters, here's our V1, at 325 degrees C, here's our T1, and remember, temperatures in gas laws must be in Kelvin, so we're going to have to change our degrees C into Kelvin. How do we do that? We simply add 273 to the degrees C. What will be its volume at 25 degrees C? So there is our new temperature, or T2, if the pressure does not change. So our pressure is remaining the same. It is not going to be in our equation. So let's list our givens. Our V1, 6.80 liters. Our T1 is 325 degrees C, and immediately add 273. Don't wait, because you are likely to forget. So we're going to immediately add our 273 to 325, and we get 598 Kelvin. No degrees sign symbol on that. V2 is what we're looking for, right? So V2 gets our question mark, and T2 is 25 degrees C. Again, immediately add 273, so we get 298 Kelvin. We're going to write the equation that we're going to use, and since we have volume and temperatures only, we've got to write Charles's law. V1 over T1 is equal to V2 over T2, and we are going to be looking for V2. So when we rearrange our equation to solve for our unknown, we're solving for V2. So how do we do that? Well, let's look at that. We have V1 over T1 is equal to V2 over T2. We want to hold V2 where it is and move T2 to the other side. Now remember, if you move a variable from one side of the equation to the other, you're crossing the equal sign, it's going to change its position. So since T2 is in the bottom, the denominator, then we are going to be moving it to the numerator of the other side. What we're doing is we're multiplying both sides by T2. That moves it from the denominator on this side to the numerator on the other side. So if it's down, it moves up. If it's up, it moves down when it is moving across the equal sign. Now remember, whatever you do to one side, you're doing to the other. So V2 is equal to V1 times T2 over T1. Oh, look, I can write it either way. Does not matter, I'm multiplying, so the order doesn't matter. So it could be written as V2 is equal to T2 times V1 divided by T1, or it can be written as V2 is equal to V1 times T2 over T1. Either way, it doesn't matter. So now we simply plug in our numbers and solve. So we've got V1, which is 6.80 liters, T2, which is 298 Kelvin, and T1 is 598. Right, it helps if I actually write it. 598 Kelvin. Cancel units that are found on the top and the bottom, and we're left with units of liters, which is good because we're looking for volume. Looking at the number of significant figures we have in our original data, all of them have 3, so our answer has to have 3. Remember, we're multiplying across the top and dividing by what is on the bottom. So we have 598 being on the bottom, and then we end up with, we're having to cut off at this first 8, so it's going to be 3.3, and then that 8 looks to the 9, or it looks to the 8 next to it and rounds up to a 9. So we end up with 3.39 as our actual answer. So this 8 rounds up to 9 because we're dropping 5 or higher. All right, let's look at 4.6. Exactly, 5 liters of air, there's our first volume, at negative 50 degrees C, there's our first temperature, is warmed to 100 degrees C, there's our second temperature. What is the new volume? So we're looking for V2. Alright, so listing our givens, we've got 5.00 liters. T2 or T1 is negative 50 degrees C plus 273. Remember to do that just as soon as you write it down. If not, you will forget, and your answers will not come out right. If you ever get a negative value from your gas laws, it's probably because you have not changed your degree C. V2 is what we're looking for. T2 is 100 degrees C plus 273 gives us 373 Kelvin. The equation we're going to use, we just have V's and T's. V1 over T1 is equal to V2 over T2. And we're going to again solve for V2. Remember, V2 is going to stay where it is, basically. I'm just moving it to the left because I like to have my unknowns on the left side. T2 is going to move up to the other side, so my V1 over T1 stays the same, but T2 moves to the other side, and it moves out of the denominator up into the numerator when it does that. Now we just plug in our givens, so our V2 is going to be equal to V1, which is our 5 liters, times T2, 373 Kelvin, divided by our T1, 223 Kelvin. Kelvin is on the top and the bottom, so it cancels. We have units of liters left, which is good since we're looking for a volume. And we have 5 times 373 divided by 223. Again, we have 3 significant figures in all of our data, so we're going to have to round. Well, actually it doesn't round, we're just going to cut it off after the 6. The 3 and everything after it just drops off. So there are 2 examples of Charles's law. There are other examples in the video on Charles's law from the homework.